Welcome to Zaption Tour 4.5, writing a function rule. There are 5 boxes for this lesson. So the essential understanding here is pretty simple. It says that you can use an equation to find a solution of a given real-world problem. So we're going to be reading some real-world problems and coming up with equations to solve them. So here is box number 1. It's an example. It says writing a function rule. You can estimate the temperature by counting the number of chirps of the snowy tree cricket. The outdoor temperature is about 40 degrees Fahrenheit, more than a fourth of the number of chirps the cricket makes in 1 minute. What is a function rule that represents this situation? So what we need to do first is, the first thing that we always want to do in a word problem is we want to define our variables. Okay? So I'm going to go ahead and choose to say let T equal the temperature. I think that's pretty straightforward. Okay? And then I'm going to let N be the number of chirps in, it says 1 minute. Okay, so N is the number of chirps in 1 minute. So the first thing that we did is you always define your variables. The second thing that you do is you need to relate your variables to what you know. I know that the temperature outside, which we're calling T, is equal to 40 degrees more than 1/4 the number of chirps. So if I take 1/4 the number of chirps and then I add 40 degrees, then I have related N, which is my variable for number of chirps, to T, which is the temperature outside, and I have come up with a function rule. Remember, a function rule is just an equation that relates the two variables that you've defined in the problem. Box number 2 is another example. It says writing a function rule. It says a landfill has 50,000 tons of waste in it. Each month it accumulates at an average of 420 more tons of waste. What is a function rule that represents the total number of waste after m months? So the first thing we want to do again is to define our variables. So I'm going to say let W equal the waste, and we're talking in tons, and we're going to let M be months. Okay, and then number 2, we want to relate these variables together. Well, the thing I'm looking for is waste. So I'm going to say that the waste is equal to, well, it already has 50,000 tons in it. And every single month, it adds another 420 tons per every single 1 month. So this would be a function rule that relates the amount of waste to m months. Box number 3 is an example. It says writing and evaluating a function rule. Concert revenue. A concert seating plan is shown below. Reserved seating is sold out. That's the part in red here. This is all the reserved seating right there, and it's all sold out. Total revenue from the ticket sales will depend on the number of general seating tickets sold. So the general seating tickets area is over here in this yellow section. It says write a function rule to represent the situation, and then it says what is the maximum possible total revenue. So step 1, let's define our variable. So I'm going to let R equal revenue. Okay, and I'm going to let N equal number of general seating tickets. So the number of general seats. Okay, so there we go. So then number 2, I want to relate everything I have. So I know that the revenue R is equal to, well, I already know that the reserved seating has been sold out. Okay, so the reserved seating costs $25 for every seat, and there are 10 rows, and every row has a grand total of 12 seats per row. So 25 represents the cost, the rows, and then the how many seats per row. Then I'm going to add to that, okay, the same idea. The general seating costs $10, okay, and I have 30 rows possible, okay, 30 rows, and then I have 16 seats per row. All right, so this would be the total number of seats that I could make in general, all right? So from here, if we calculate how much this is, right, 25 times 10 times 12, we get a grand total of 3,000. Okay, so they would generate $3,000 just from the reserved seating alone. And then from here, if we calculated 10 times 30 times 16, I'll do that real quick over here, we would get $4,800 from the general seating section. So the maximum total number of revenue that we could create would be $7,800. So this answers sort of the second part here. What is the maximum possible revenue total, right? If I wanted to just figure out the general rule, then I would say this. I would say that my revenue would have to be equal to the 3,000 that we get from the sold out reserved seating section plus 10 times n, where n is the number of general seats. So we would plug in 480 for the general seats. This number right here gives us the 480 because there are a grand total of 480 seats. So this right here represents the function rule, and this value right here represents the maximum, and we get that maximum from plugging in a grand total of 480 seats into the number of general seats. Box number 4 is a you try. It says a kennel charges $15 per day to board dogs. Upon arrival, each dog must have a flea bath that costs $12. Write a function rule, so we want a function rule, for the total cost for n days of boarding plus a bath. And then it says, how much does a 10-day stay cost? Hopefully you got the right answer, but if not, here's the solution. So step number 1, I said let n equal the number of days of boarding, and let c equal the cost. So I've defined my two variables. Then in step 2, I wrote down that the cost is equal to 15n plus 12. The 15, because it says $15 per day. The 12, because of the $12, they have to get a flea bath. So once I finally have my function rule, step 3, I want to know the cost of 10 days. So I would plug in 10 for n and get $162 for 10 days. Box number 5 is writing a non-linear function rule. Geometry question. Write a function rule for the area of a rectangle whose length is 5 more than its width. That's the first part. Then it says, what is the area of the rectangle when the width is 9 feet? Okay, so this picture represents our normal picture of a rectangle, where it says that the area, of course, is equal to the length times the width. And we learned that back in geometry class, or we will learn that back in geometry class. Wow, I can't make a W. There we go. But then it says the length is equal to 5 more than the width. So we know that the length is equal to 5 more than the width, so that'd be W plus 5. That's why it has over here. See, here's the length, and then in my new drawing, W plus 5, these two things are equal to each other. So the function rule itself would be this. The A would be area, would be equal to the length times the width. But now we replace L with the W plus 5. So the area would be L, this would be W plus 5 multiplied by W. And that simplifies to when we distribute W squared plus 5W. So our function rule is area is equal to 5W plus W squared. Okay. Then the second part says, what is the area if the width is 9 feet? So then I would plug in, well, the area would have to be 5 times 9 plus 9 squared, because it says the width is 9 feet. And we would just compute this. So 5 times 9 is the 45. 9 squared gives me the 81. So putting it all together, I get 126 for the area of a rectangle where the width is 5 or the length, sorry, is 5 more than the width, and the width is 9 feet. So this is my answer, and this would be area would be feet squared.